This is Mrs. Huntley. This is lesson 4 from our functions packet. Please get your function packet out and open to page 16. On page 16, you should see in the top left-hand corner where it says Unit Functions Student Handout number 4. If it's not on page 16, it should be close to page 16. Add the essential question in the top left-hand corner or top of the page, doesn't matter if it's in the left-hand corner. How do I write an equation from a table or a graph? Now you might be thinking, I already know how to write an equation from a table or a graph, and honestly, you should. We've been writing equations from graphs since about January when we first started learning slope-intercept form and we first started seeing things with two variables on them. So this is not necessarily a new idea, but maybe some new vocabulary. And we haven't explicitly been writing equations from tables, although the ideas have been there and we've been finding slope from tables or rate of change from tables for a long time also. So let's do some fill in the blank notes. Writing equations from tables and graphs. We need two pieces of information in order to write the equation of a linear function. I'm hoping you remember what they are. So before me revealing my answers, can you fill in the first two fill in the blank notes? So the M represents the slope, the B represents the y-intercept. So we need those two pieces of information in order to write an equation in slope-intercept form. And of course, slope-intercept form is our y equals mx plus b. Everything should be in that order, okay? Whatever is being multiplied by the x is your rate of change or your slope. Okay, from a table, we can find the slope by calculating, and we have three different methods that we can use. We can use the slope formula, the Larkin L, or the change in y over change in x. And remember that triangle, that's a delta y over delta x, and delta stands for change. So we have those three methods. You can use whichever one you are most comfortable with, and you should get the same answer regardless of which one you use. So we look for the y-intercept as the value of y where the x value is equal to 0. So you look on your table, and wherever the x has a 0 in it, whatever the y is equivalent to, that is your y-intercept. From a graph, we find the slope by setting up a ratio of rise over run. So the change in your y over your change in your x. Look for the y-intercept as the point where the graph is crossing the y-axis. Again, these are not new ideas. We've been doing this for quite some time. So let's look at some real-world situations. So Luke's family is going to the movies, and let's see, they're debating about whether or not to purchase any drinks. The table below shows how much they'll spend based on the number of drinks they decide to purchase. Oh, I'm sorry, large popcorn. So they're buying some popcorn, and they're debating whether or not to purchase any drinks. So let's take a look here. At 0 drinks, we're spending $6.25. So again, from looking up here at our notes on a table, look for the y-intercept as the value of y where the x value is equal to 0. So our y-intercept in this table is $6.25. That one's pretty easy to figure out. What is the slope? So again, I can calculate the slope any of the three ways that I talked about. I can look at the slope formula, Larkin L, or change in y over change in x. Now, you might have your favorite, and if you have your favorite way of finding slope from a table, why don't you go ahead and pause the video right now, and I'm going to show one that we don't often use. So pause the video, figure out the slope, and then when you come back, you'll see if it's right or not. I'm going to do change in y over change in x. So what I'm going to do is this is my y, my total cost, and my x is my number of drinks. That's the thing that potentially will change. Now the change in x is easy to see. Going from 0 to 1, that's a plus 1. 1 to 2, plus 1. 2 to 3, plus 1. What's not quite as easy to see is the change in y. Okay, from $6.25 to $10, what is the change in value there? Now, if you're really good at counting up money, you can go from $6.25 to 7, that's 75 cents. And then 7 to 10, that's $3. So it's a change of $3.75. You might be going, wait, what just happened there? Okay, if that didn't make sense to you, what you could do is grab your calculator and do 10 minus 625. So it's kind of going a little bit backward. We would take our larger number or our second value and subtract our first value, and that would get our change and what we'd have to add to the first value to get to the second value. Now, it might be a little bit easier to start at this whole number 10 and go up to 13.75, 10, 11, 12, 13. That's our $3 and then 75 cents. So regardless of which points you count it between, you're going to count it between those points. Let's see, our change in y is $3 and, oh, so I'm just going to say delta y over delta x. So I've got 3.75 over 1, or just plain old 3.75. So my slope here is 3.75. And I just showed you the change in y over change in x method of finding slope on a table. So write the equation. I might be going slow for some of you, so you might be fast forwarding. If that's the case, that's great. The slope is $3.75 times x, that would be the number of drinks I'm thinking about getting, plus the $6.25 that I've already spent. And there we get our stray marks again. Let me get rid of those. Okay, so now we have some practical questions to answer here. What does the slope represent in the situation? So what is $3.75? Let's go back and read this. Luke's family goes to the movies and purchases a large popcorn. They are debating whether or not to purchase any drinks. So X is our number of drinks and Y is our total cost. So what is this $3.75 representing? If you have an idea, go ahead and write it down. And then we'll see if we're right. $3.75 is the cost of each drink. What is our slope, or I'm sorry, what is our y-intercept representing in this situation? That's our 625. So before any drinks are purchased, we've purchased a large popcorn. So the popcorn costs $6.25 without any drinks. Okay, I hope this is starting to make sense, and I hope it's starting to get to a point where it's not confusing anymore. I can see why the tables might be confusing still, but really our graphs should be pretty straightforward. We've been counting slope and writing equations from graphs for a long time. So please pause the video right now and figure out the slope, figure out the y-intercept, write an equation, unpause the video and see if you're right. Okay, so hopefully you figured out the slope, you figured out the y-intercept, and you wrote the equation. If you said y equals 3/4 x plus 0, that's fine too. And you know what? I just realized I did this without even reading the question. So let's go back and read the question. Betty's Bakery uses a chocolate chip recipe that calls for a certain ratio of brown sugar to butter as shown in the graph. So my brown sugar is my rise, my butter is my run. So 3 cups of brown sugar, 4 cups of butter. 3 cups of brown sugar, 4 cups of butter. So what does the slope represent in this situation? Come on, there we go. Did I say butter before? Oh, I hope I said it right before. I don't remember now. 3 cups of brown sugar to 4 cups of butter. 3 cups of brown sugar to 4 cups of butter. Hopefully I said it correctly. Been a long day. Okay, what does the y-intercept represent in this situation? When we haven't used any brown sugar, we haven't used any butter. So at 0 cups of brown sugar, we've got 0 cups of butter. Okay, number 3. A plane uses a certain amount of fuel based on the number of miles it travels as shown in the table. So again, we have another table. Miles traveled, 0. Gallons of fuel, 0. So hopefully right now you're thinking about the y-intercept and what the y-intercept is. Go ahead and fill that in. And then pause the video. Using whatever your favorite form is to figure out the slope, go ahead and figure out the slope and write that in as well. So our y-intercept is 0. Ooh, that's pretty. And our slope. I'm going to do the change in y over change in x again. This is y, this is x. 0 to 156, that's a plus 156. 0 to 30, that's a plus 30. Change in y, 156 over change in x, 30. 156 divided by 30 is going to be 5.2. So hopefully when you calculated your slope, however you calculated it, you came up with 5.2. Write an equation. Y equals 5.2 times x, and I could say plus 0, but I don't have to. If there is no plus 0 there, it is assumed that it is a proportional relationship, and the line is going to cross the y-axis at 0. So what does the slope represent in this situation? So we've got 5.2 is our slope. This is miles traveled, gallons of fuel. Go ahead and write down what you think the slope represents in this situation. I say the plane uses 5.2 gallons of fuel per mile. What does the y-intercept represent? At 0 miles traveled, 0 gallons are used. So hopefully your answers are mirroring mine as you're pausing and coming back. Let's take a look at one more situation here. We have another table or another graph. Okay. So Robert pays for his family to go bowling. He rents shoes for everyone, and then he pays a certain amount per game that his family plays as shown in the graph. So I would like you to pause the video, figure out what the slope is, figure out what the y-intercept is, write an equation, write what you think the slope is representing and what you think the y-intercept is representing in this situation, then unpause the video, see if you're correct, and then we'll move on from there. Okay, so hopefully yours looks like mine. The slope is, I'm going up 9. Look, it's not going up by ones, it's going up 3, 6, 9 over 2. 3, 6, 9 over 2. So it'd be 9 over 2 or 4.5. Y-intercept, where is it crossing the y-axis? And that would be at 12. Writing my equation. This should not be super hard anymore because we've been doing it for so long. If you're still struggling with these ideas, please, please, please come in. Let's clear up your confusion. Let's make sure that we understand it. The slope, what is it representing? $4.50 for each bowling game. What does the y-intercept represent in this situation? They spent $12 on the shoe rental before they even paid for one game. Okay? Now, it doesn't mean that's $12 for one person. We don't know how many people are in their family. So this might be, I don't know, maybe there's 6 people and it's like $2 per shoe rental, but that's not information that was given to us. So, summarizing today's lesson, we can write equations from graphs and from tables. We need 2 key pieces of information. We need the slope and the y-intercept, and then we write the equation in the format y equals mx plus b. Okay? From a table, we can calculate the slope by doing either the slope formula, the Larkin L, or change in y over change in x. We look for the y-intercept as the value of y where the x is equal to 0. Wherever that is, that's our y-intercept. Of course, on graphs, we're doing our ratio of rise over run for our slope, and our y-intercept is wherever that line or wherever the graph is crossing the y-axis. So I hope you enjoyed this little review of writing equations from tables and graphs. Again, if there's anything that is still confusing to you, please ask me and we will get that cleared up, because this is, obviously we're going over this several times. This is a key concept that you need to have for high school algebra. Okay, have a good night. We'll see you in class tomorrow.